And so far we've learned kind of the process of a hypothesis test, and we've come to the part where we make a decision. So when you perform a hypothesis test, you make a decision. What are my two decisions? We either do what or what? Reject or fail to reject. Write that in. However, when you make one of these decisions, you could potentially be wrong. Could have made an error. So we hope that you're not wrong, but there is a small chance that you could be wrong when you made that decision. You can't be 100% sure. So there's two types of errors. We have type 1 and type 2. And it all depends on the decision that you made. A type 1 error is when you reject the null, but the null is actually true. And the probability of that is called alpha. So this, I guess when I was making it the same font, it didn't change this over. But this should be an alpha. So the only time you can make a type 1 error is when you reject. Incorrectly rejecting. And alpha is also called the what of the test? Does anyone remember?
P-value.
Not the p-value. No.
Oh, I know.
Starts with an S.
Sample size determination.
Significant level. Significance level. There's a cute little owl. Yeah. Level of significance or significance level.
I have a serious question.
Yes.
Not on the list.
Okay, then we can't talk about it right now. I am videoing. Remember, this is how tolerant you are. We all did that little, that test. That's your significance level. You use 0.05. Okay, a type 2. Reject a true hoe. You could also write that as well.
I like that.
I love to do that.
What's the case?
Oh!
I haven't seen that one.
Okay, type 2. That's when you fail to reject, but the null is false. We call that beta. And I'm going to change that for you. Looks like that. That's beta.
Actually, just not like beta. Well, why would you? I don't know. Okay, I'm trying. Apparently, I'm like Hitler, so it's fine.
Type 2 is when you incorrectly fail to reject.
Might have had a few of those on quiz.
So here we might say type 2 is when you fail to reject a false hoe. So type 1 is when you reject a true hoe. Type 2 is when you fail to reject a false hoe. What?
I just
Sure.
think we should reject hoes.
It's called catfishing for a reason.
We failed to reject a fall.
Oh! Yep.
Of course, these concepts.
Okay, so copy down this chart. This is something that you will want to write, like right when you get your test. You'll want to write that at the top so that you can always refer to this chart or this table. So what it means is, if I reject, so I make the decision to reject, I could either be correct, or I could have made a type 1 error.
Well, what's his name? Catfish.
I don't remember.
That's gonna help me remember to reject.
I'll look it up. Okay, I'll text my friend. If I fail to reject, so if I make this decision and the null hypothesis is true, I'm correct. If it's false, then I made a type 2 error. Everyone have it copied? Yes. Okay, now, here's what you would see most likely on a quiz or test. It would say, explain what the type 1 or type 2 error is in context. So these are technically scripts that you need to memorize. And the way that I memorize it is it looks very similar to your conclusion. So, type 1, type 1 is when I reject. And so when I reject, I say there is sufficient evidence to suggest the ha, when in reality, the ho. So I say ha ho.
Ho ha.
And then type 2, I have failed to reject. I've failed to reject, so I say there's not sufficient evidence to suggest the ha, when in reality, the ha. So ha ha.
Oh, ha ha.
Ha ho ha ha.
If someone didn't know what we were talking about,
I know, it's stats is a weird language, let me tell you.
No, I was.
Consider the murder trial example. I already have the hypotheses written for you. So, the null hypothesis was that the defendant was innocent.
it's already written.
And the alternative was that the defendant was guilty. So, a type 1 error. Shh, stop talking. A type 1 error in context. We're going to refer back to our script. I would say there is sufficient evidence to suggest what's the alternative hypothesis? The defendant is guilty. When in reality, yep, the defendant is innocent. What would the type 2 error look like? Try to fill that one in. So it's kind of like the opposite. So there's not sufficient evidence that they're guilty, when in reality they are guilty. Aha.
That's what the defendant would say. Ha.
Follow-up questions, and this isn't a script you have to follow, it's just something you have to think about. We have to use our brain. What are potential consequences? What's the consequence of a type 1 error? So we say they're guilty, but they're actually innocent.
Innocent person in jail.
An innocent person goes to jail.
We should write these.
Now, yes. A consequence of the second one, we say an innocent person goes free, or a guilty person goes free. Which one does society believe to be more serious or more consequential?
A.
The second one.
The second one.
Society are more.
Society.
The second one.
Terrible. No.
A guilty person goes free is more.
Do we ever know if a guilty person goes free? Do we ever really find that out?
I think O.J. Simpson went free.
But you don't know the other one, either.
We do.
What's his name? The guy who killed Trayvon.
So I'm going to say type 1 is more, society believes that to be more consequential, just because we're sending someone that did nothing wrong to jail. Yeah. Okay, I want you to try. We're going to do the hypotheses together, and then I'm going to have you do the type 1 and 2, okay? So, here we have an airline company that claims, the overall claim is that 72% of domestic flights are on time.
That's a lie.
And that means within 15 minutes of their scheduled time. Yes.
Oh, okay, within 15 minutes.
Yeah.
Maybe.
Suppose an airline with poor on-time record decides to offer its employees a bonus if they exceed that rate of 72%. So we want to get higher than that. So what would the hypotheses look like? The null is
Ho equals 0.72. Ho is greater than.
perfect. Where P represents
Average amount of flight time.
proportion, true proportion
To population proportion.
of flights arriving on time. Good. Now, I want you to fill in type 1 and 2 errors. Try it on your own. You can refer to the script. You're filling in the null and the alternative. So type 1, we say there is sufficient evidence that it exceeds 72% or exceeds the industry rate, when in reality it's equal to 72%, equal to the industry rate. So you don't have to write this down, but let's think about a consequence for, no, you have to write down the entire error. I'm saying we don't need to write down the
Then
consequence,
they're
but
paying
let's
their
talk about
employees to
it.
do nothing. They're paying their employees extra for no reason.
So they're giving their employees a bonus, but they don't deserve it. They don't deserve it.
I'd be okay with that.
Okay, type 2. There's not sufficient evidence that it exceeds 72%, but it actually does. What is the consequence of that happening? Do the employees get their bonus?
No.
Should they?
No.
Yes, they should, but they don't get it. So these hypotheses are written in words because there's no numbers at all. Okay? There's no numbers to be used. So, Gabby, are you listening? No, you're not. But thanks for saying that. So there's no numbers. Most of the time, and you'll see some that are like this, it's talking about an experimental drug that's trying to slow the rate of tumors, which is actually a very serious topic, but it's being used. They're trying it out and testing it. And so whenever you're writing null and alternative hypotheses for these, I provided them for you, but on the homework, it won't be. So here's kind of your rule of thumb when the entire problem doesn't have any numbers. The null hypothesis is basically that nothing changes, nothing happens. It stays the same. The alternative is what you want to happen. So in this case, we want this drug to slow down the growth rate of tumors. So the null hypothesis is nothing happens, it stays the same. And then the alternative is what we want to happen. So I think that there's one or two on the homework that kind of have a similar scenario. There's no numbers at all in the prompt. So think about your null being, and it doesn't all have to be the exact same, but the null is nothing happens. The alternative is what we want to happen. So if we were to phrase type 1 and 2 from this, type 1, we would say what? Let's just say it out loud.
There's sufficient evidence that to suggest that the drug slows tumor growth when in reality it doesn't.
Perfect. Perfect. So there is sufficient evidence, I'm just going to shorthand it, to suggest the experimental drug slows growth rate of tumors when in reality it doesn't. What would a type 2 say?
There is not sufficient evidence to suggest drug slows down growth tumors, but it does.
Perfect. So type 2, it says there is not sufficient evidence to suggest the drug slows growth rate of tumors when in reality it does. So type 1 is saying that we think it's slowing it down, but it's not. Type 2 is saying we don't think it slows it down, but it does. All right, the last thing, so this is like the first part of the lesson, is just being able to regurgitate what it's saying, like what each type is. So type 1 and type 2. The second thing is talking about the relationship between alpha and beta, because ideally we would want both type errors to be 0%. Like we would not want any error to ever occur, but that's not possible. So alpha is for which type? Type 1, and then beta is for type 2. They are inversely related. What does that mean? The opposite. So if alpha goes up, beta goes down. Alpha goes down, beta goes up. So one is going to be higher than the other. Alpha is always chosen by the researcher. Remember, it's always given in the problem, your significance level. It says use alpha equals 0.01 or alpha equals 0.05 or 0.1. It's always chosen by the researcher, but we don't have any control over beta. So how do we know which alpha level to use? Like, how do we know to use 0.01 or to use 0.05 or to use 0.1? How do we know which one of those to use as a researcher? Like, because it's always given to you, but how does that researcher choose it, I guess, is the better question. And so they have to decide beforehand which type of error is more serious or more consequential. So if we go back to the murder case trial, we agreed that type 1 error was more consequential or more serious. So we would want a really small alpha. That makes sense. Like we want a really small chance of that occurring. So it just depends on, do we think type 1 is more serious or type 2? If we think type 1 is more serious, we choose a really small alpha, like 0.01 versus like 10% or 0.1. If we think that a type 2 is more serious, then we choose a larger alpha. That was weird. I don't know. Choose. Just trying to sing it. I thought y'all might like ignore it, but I guess nope, y'all were the only ones.
I thought about music for a second.
Oh God.
Because I swore that was my music.
It was. Just trying to sing for y'all. You should.
Yeah.
Wait,
what mark is this? So I can go back it out.
Like 1840 or something.
1840?
Okay. Yeah. So if type 2 is more consequential, you choose a larger alpha, which will then decrease beta. Okay? Does that make sense?
Talented.
Yeah.
You want to sing to us?
Yes.
No. Okay, we're going to do 2 more things. 2 examples that aren't on your notes, but we're just going to get a little practice. So wait, hold on. Before I go to this slide, I have to preface this. So this slide, if you are squeamish or if you think that you're afraid of blood or something, you might just want to like close your eyes or put your head down. It's pretty graphic. What I'm about to show you.
It's going to be a snake picture stabbing.
Oh no. Oh my god.
Close your eyes.
Is it bad?
I don't think I can handle it.
Okay, is it bad?
I know what you're gonna show.
I know.
After we started dissecting cats, like it's just
Oh, I just realized what she's doing. She's like killing her.
No. Let's give her a shot. Okay.
Miss Thornhill, we started dissecting cats and anatomy.
All right, listen. Shh, this is the last thing. So here is the prompt, or here is the scenario. How many of you have ever gotten a flu shot? How many of you have ever gotten the flu after getting the flu shot?
It's so dumb.
so passionate.
Yeah.
I don't get the flu when I don't get a shot, but I get the flu when I do it.
So this flu vaccine claims that it works 70% of the time, but we all think it's less than that, right? Because it's just it's not true. I think it's way less. So we're going to identify, we're going to read now the scenario. So it's going to go backwards. We're going to read it and decide if it's a type 1, a type 2, or a correct decision, okay? So here it says, there is sufficient evidence to suggest that it's less than 70, when in reality it is less than 70. Type 1, type 2, or correct? Type 1, type 2, or correct? Everyone should be reading.
2.
So we say that it's less than 70, when in reality it is less than 70.
Oh, when that's correct.
It's correct. So read it again. We have sufficient evidence to say that it's less than 70, when in reality it is less than 70.
True.
So that's a correct decision. Okay? Okay, one more. So this one says there is not sufficient evidence that it's less than 70,
That's 2.
when in reality it is less than 70. We'd say that's a type 2. Good.